Hello, my dear NEET warriors. Welcome to the RNA series, your Roar NEET Aspirant series. Welcome aboard. I hope you are ready to roar. And if you are ready to roar, let me know in the chat box that yes, sir, we are ready to roar with your captain Shreyas. Welcome, Naina, Satyashri, Pavitra, and so many more students. Welcome. Now, see, guys, I have chosen addition, subtraction, and resolution today because this is one of the most crucial part about vectors. And please don't treat vectors like a chapter. Rather, you should treat it like a tool, like a skill, which you will need during your entire physics course. Like if you're a dropper, you already know that maybe in Newton's laws, or maybe somewhere in electromagnetism, or maybe somewhere in fluids, I will need two or more vectors to be added, to be subtracted, and I should be very comfortable with it rather than recollecting all the steps. What is the formula? What is that? What is this? You should be able to do it in a very fluidic manner, in a very natural manner, just like you know how to write, just like how you know to walk, right? So that is the whole purpose of this video. Because if you open up the previous year papers and then you realize, wait a minute, vectors is not at all high weightage, why am I even doing it? I don't see any specific question from vectors very often. So a lot of students do this mistake, so don't do that. And I'm glad you are choosing to watch this video with me, your captain Shreyas. Good evening. Hello, Asim. Hello, Pratibha Sadeshri. Hello, Neha Marma. Hello, Yama. Welcome. Now, those of you who do not know me, my name is Captain Shreyas. You can call me Capto or Captain. And I have been teaching for more than 13 years now. And before that, I was in software, right? So I've done my graduation from NIT Nagpur, done my, yes, research from IIT Bombay. And here I am to send all of you to the best institutes in the country. And I'm sure that with this particular channel, with the guidance, with the content that you're getting, you will be able to crack it. And I say this with utmost certainty because we have been doing so year after year after year, predicting questions, giving the right approach, and teaching quality content. So let's begin with the class, and let's start with what is a vector, what are the different types of vectors, and then we'll slowly get to vector addition, subtraction, and basically how to operate on vectors, right? So first of all, any physical quantity, if you remember, what is a physical quantity? Physical quantity is something which can be measured. Anything which can be measured. Like when I ask you how excited you are, you put some five emojis, five fire emojis, or you press the like button. Hopefully you have done that. If you have not done that, please do that. Yes, you show your excitement. It can't be measured. We try to measure it by the number of likes, right? Okay. But things like temperature, distance, how fast you are, that is velocity, how fast you are changing your speed, that is your acceleration, force, momentum, all these things are physical quantities because they have a number associated with it. Yes. And these physical quantities can be categorized into two parts. One is scalar, one is vector. Scalar, a lot of people say, sir, it is just like me, sir. My life, sir, is like a scalar, sir. Why so? Sir, I don't have direction in my life. Sir, I just have some number. I have marks. I have got these many marks in NEET. But sir, I don't have direction. Sir, I'm getting these many marks in my mock test. I have magnitude. But sir, I don't have direction. Don't worry. I will make you a vector if you attend the RNA batch. So guys, vector is something which has direction and which needs that direction for defining it. Scalar, no need of direction. Even if it is there, not bothered. That's what a scalar is. Exactly. Awesome. Great. Cool. Everybody agrees with this. Perfect. So scalars are basically typically those quantities which can be described completely by its magnitude. They don't need direction, just a number. There are many examples of scalars like speed, volume. Nobody will ask you, Hey, you were driving that day at 40 kilometers per hour, top speed. Was it in north or was it in east? You'll give one touch slap. What is the meaning of north and east? Just ask me what is my top speed. Don't ask me such rubbish questions. Volume. Get a can of water, 10 liters. If you ask, sir, should I get it in north direction or east direction? You'll be like, what is this? Mental fellow only. Mass. If somebody asks you, what is your mass? And you say 40 kg. Somebody asks you, up direction or down direction? You will only look up and down. What is he asking, bro? Up and down? My mass? Temperature. My temperature is 98 degree Fahrenheit. Normal body temperature. Up or down? You'll be like, what nonsense? Don't crack non-veg jokes. Okay. Power. I'm very powerful. I give a power of 100 watts. Which direction? Nobody cares. Energy. I have 100 joules of energy. I ate this vada. It gave me 5 calories of energy. Which direction? Down, up, left, right? Oops, no. Time. Sir, what time is your class? 5 o'clock. Sir, which direction, sir? Should I go to north direction, sir, or east direction, sir? Hey, Macha, what are you saying? North or east? Come at 5 o'clock. That's it. No need of direction. Exactly. So that is basically scalar. Then when you talk about vector, you need to tell me the direction. Exactly. Exactly. You need to tell me the direction. Apart from the value. Like for example, listen, you pull that person with 100 Newton force. Then you will ask me, sir, which direction, sir? Then I'll say, apply 100 Newton force and pull him towards me, towards him, towards her. So, direction. Velocity. What is the bus's velocity? Sir, it was moving at 50 kilometers per hour towards my home, sir. Okay. What is the acceleration? Sir, that super fast car, sir, it was accelerating with 10 meters per second square towards the east direction. Displacement. I moved from here to here. What was my displacement? Oh, sir moved towards the right, maybe 3 meters. Momentum. What is the momentum of this particular body? Sir, the momentum was 10 kg meters per second towards you. So they all need direction. And they will also follow certain rules of vector algebra, which we are learning today. Yep. I hope this is absolutely clear. Correct. Now that you understand, okay, sir, I understood what a vector and what a scalar is, sir. Lot of students ask me about current. Sir, will current be a vector or a scalar? Let's see if you guys can answer this. Come on, fight it out. Is current a vector or a scalar? Lot of students have this doubt. Come on, my dear students, my dear lions. Current is a vector or a scalar? Like current, 5 amperes current. What is the direction? Current is flowing in the wire from the positive terminal to the negative terminal. Okay, direction is there. So, sir, current is a vector quantity. The answer is no. It is not a vector quantity. You'll be like, sir, why, sir? Because it does not follow the laws of vector algebra. It does not follow the laws of vector algebra. All the 3 conditions should be satisfied. Only then it is a vector. You cannot add current like you add vectors. You just add 2 amperes plus 3 amperes is 5 amperes. It's just pure numerical addition like scalars. Like 2 kg plus 3 kg is 5 kg. 2 amperes plus 3 amperes is 5 amperes. But 2 Newton plus 3 Newton, maybe 5 Newton, maybe something else Newton, because there is vectors involved. The direction also matters. All the 3 conditions should be satisfied. It does not follow it. Now, how do I represent vectors? Very simple. I want to show that, listen, there was a person who moved from here to here. I show an arrow from the start, which I call as the tail, to the end, which I call it as the head, and that arrow mark specifies the direction. The length of this shows the magnitude. Do you see the length of this arrow mark? Shows me the value, the numerical value. 5 Newton, 100 meters per second, 10 meters per second square, the magnitude or the value of the vector. And when I put A vector, symbolically, I should put a bar or an arrow mark. When I was your age, I used to always think this, sir, a bar is a vector, okay, a arrow mark is a vector. Sir, this shows the direction, huh? So I used to think like this. This shows the direction. So I used to think, sir, if a person is moving towards the north, no, so I will show like this. If a person is moving towards the left, I will show like this. If a person is coming down, I will show like this. No, it is representing that it is a vector, but it is not pointing in the direction of the vector. It's just a representation. So do not do all such rubbish things. It is just a representation that, hey, listen, this is having direction. It is not telling what direction. The direction will be specified in words. The direction will be specified in words. Like, for example, I can say V bar. This is velocity. What is the velocity of Pandu? The velocity of Pandu is 20 meters per second in the north direction. Do you see it has the magnitude information over here? It also has the directional information over here. It is illegal to say 20 meters per second. It is also illegal to say just in the north direction. This is illegal to say that because I'm either missing on the direction or the magnitude. So it is wrong when I put a bar to only give magnitude or direction. I have to give both, only then it is correct. Then you might be wondering, sir, if I just put this bar, sir, then does that mean only north? Does that mean only north? No, 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 no. It does not mean only north. So just don't put only the bar. It does not mean anything. It does not mean only the north direction. That is wrong information in case you thought so. Sir, what if I only want the value, sir? No issues. If you want only the value, just put this. Or forget the bar, just write this. One and the same thing. One and the same thing. This is just magnitude. So that is 20 meters per second. So when you put modulus symbol over there, that means the magnitude of the vector. The magnitude of the vector quantity. Or just skip the bar. It is just the magnitude of the vector quantity. Excelente. Excelente. Very good. Very good. Awesome. Now, let's see if you can solve these NCERT questions, my dear students. So, by the way, there is a big change coming next week. I'll tell you what that big surprise is. Coming this week on Monday, something amazing is going to happen on this channel. Okay, so stay tuned, guys. And in case you have not yet subscribed to the Vedantu NEET English channel, please do that right now. State for each of the following physical quantities if it is a scalar or a vector quickly. Okay, let's mark scalars in pink. Let's say, for example, so volume, yes, scalar. Mass, scalar. Speed, scalar. Acceleration vector. Density, scalar. Number of moles, scalar, no direction. Velocity vector. Angular frequency, scalar, omega. Okay, displacement vector, angular velocity, vector quantity. So basically, this is a vector, this is a vector, this is a vector, and this is a vector. So all these blue ones are nothing but vectors, and all these pink ones are nothing but your scalars. I hope that is correct. Everyone with me? Great. Awesome. Moving on to the next question. Pick out the scalar quantities in the following. Among them, so these are all NCERT questions. Let's quickly do these questions as well. Which of the following are basically scalar quantities out of all of them? Force vector, angular momentum vector, work, yes, scalar. Current, yes, scalar. Linear momentum is a vector. Electric field has a direction, it's a vector. Average velocity, the moment velocity comes, whether it is instantaneous or average, it's vector. Magnetic moment is also a vector. Relative velocity is also a vector. So the only scalar quantities are work and current in this entire big list. Only work and current. That's all. Rest everything has direction, and you are going to treat them like vectors. Pick out the vector quantities. This is the next question, my dear students. Pick out the vector quantities among the following. Temperature, pressure. Temperature is scalar, no direction. Pressure is also scalar. Impulse is the change of the momentum. It is a vector quantity. It has a direction. Apply impulse in that direction. Time is a scalar, no direction. Power is a scalar. Total path length, it's like distance. Distance is a scalar. Energy is a scalar. Gravitational potential, scalar. Coefficient of friction, scalar. Charge, also scalar. So the only vector among them is just impulse. That's it. Only impulse. Only and only impulse. Coefficient of friction has no direction. So does charge. Charge has sign. A lot of people think, sir, charge can be positive, negative. So negative means this, positive means that way. No. Just because something has sign does not mean it has direction. Okay, so don't get that thing wrong. Exactly. Very good. Awesome. Now, what are the different types of vectors that you will encounter? Let's go about it really quick, depending on what they look like, how they are oriented, etc., etc. First is a zero vector. Imagine we have a donkey which does nothing. Some people get scolded by their parents also. What a donkey you are. You just stay there whole day and you don't do anything. So a donkey at rest. So we have a donkey at rest. If I write, what is the displacement of that donkey? The answer will be 0. It is at rest, it is not moving. So it is 0 meters, nothing. So it's 0. 0 bar basically is a null vector. If I show it as tail and head, it will be just a dot. So a dot representation, dot representation. Basically, there is no tail or head. There is no tail or head. If you ask me what is the direction of null vector and what is the magnitude? Well, the magnitude is nothing but 0. The magnitude is basically 0. And this is the most important thing. Direction is not defined. This is the only vector. This is very, very important, my dear warriors. This is very, very important. This is the only special vector for which direction is unknown because it doesn't make sense. But any other vector which has some value, magnitude, length, it has some direction. 5 meters, 0.1 meters, 100 meters, whatever. But 0 does not have only any direction. Keep that in mind. Yes, it is directionless. Just like some of our lives, we are very clueless, directionless, because Supreme Court verdict is pending for the NEET, whatever, re-exam, no re-exam, etc. So we are like null vectors. Some of us are rest. We don't know what to do in life. Exactly. Unit vector. The name only suggests everything. Unit vector means the magnitude is 1. The magnitude is basically 1. That is basically a unit vector. And I can say A bar, if modulus is 1, therefore it is a unit vector. It is basically a unit vector. Now, if by chance A bar is not equal to 1, it is not a unit vector. But imagine there is a vector P and I put P hat. It is 100% a unit vector. It is 100% a unit vector the moment I put a cap or a hat. The moment I put a cap or a hat. So guys, always whenever you put a hat or a cap, you become unity. So the answer will always be 1. Okay? Anything. If I put, let's say, something like B hat, B cap, whatever you want to call, answer is 1. Answer is basically 1. Now, there are special 3 unit vectors. 3 special unit vectors in our life. Hello, Poeta. Welcome. Baswa sir, 1 direction, no direction. Oops. Baswa sir is trolling you. Nice. Okay. So, guys, we have 3. Yes, we have 3 special unit vectors and they are called as I cap, J cap and k cap. I is in x, y is in, sorry, j is in y, and k cap is in z direction. These are your special unit vectors. So I cap, j cap, and k cap are basically your special unit vectors. They are special unit vectors along x, y, and z respectively. Along x, y, and z respectively. You will see their usage later on. You will see their usage later on. Okay. So I, j, k are the names given to those vectors whose length is 1 in the x, then in y and z. The length is 1, 1, 1 exactly. Keep that in mind. Next, position vector tells me the position. Imagine we have a Pandu. Pandu is observing everything around him. This is the x-axis for Pandu, this is the y-axis for Pandu, etc. Pandu is at the origin, he is the observer. Pandu, who does he see? Obviously a Champa. So this is the Champa who Pandu is observing. So what is Champa's position with respect to Pandu? That is represented usually by R bar. R is the symbol generally used for position. The bar represents that it is a vector quantity. So R bar basically tells you the position vector of any particle that you are observing, any person you are observing, any body that you are observing. So as this person moves, as this particular Champa moves, this position will also keep changing. This vector will also keep changing and pointing towards that particular object that you are observing. Got it? Krishna, very good. Thank you so much. Very good. Thank you for trending WP, all the warrior Pandus. Thank you so much. Yeah. So that is your position vector. It points towards that particular particle which has some x, y, and z coordinate anywhere in space. Perfect. Okay, so that is position vector. Now, what is parallel and anti-parallel vectors? Pandu, okay, decides to follow alongside Champa. Champa was going like this. This is displacement of Champa. Okay, this is displacement of Champa, so I'll put it C bar. Pandu decides I will follow whatever Champa is doing, so Pandu was behind her. Sometimes he overtakes her, sometimes he's behind her, and when Champa stops, he continues as if acting normally, as if nothing has happened. So the C vector is parallel to the P vector. Their lengths may be same, may not be same, but their direction is same. Alright, the direction is basically same. So as long as basically direction is the same, they are called as parallel vectors. But why did Pandu decide to follow Champa? That is the question, right? So what happened is, day before, what happened is Champa, Pavam, she was going like this. Champa was going like this. Pandu was coming the opposite way. Pandu was coming the opposite way. Directions were opposite. Pandu saw Champa, decided I have to follow her tomorrow. That's what happened. So here C is basically anti-parallel to P. Directions are opposite. Directions are exactly opposite. Directions are exactly opposite. That is basically anti-parallel. Excellente. Very good. Coplanar means same plane. Like for example, if I draw anything in this board, they are in the plane of the board. But if I hold this pen is out of the plane of the board. So it is non-coplanar. So anything in the same plane is coplanar. Anything outside that plane is non-coplanar. Same plane. You have to visualize that in 3D plane. Okay, as simple as that. Collinear. Collinear means along the same line. For example, this vector, this vector, this vector, this vector, all of them are collinear because they are along the same line. Along the same line. Directions may be same, opposite, that's okay, but along the same line they should be placed. They cannot be something like this. Even this is not collinear. See, this they are side by side. No, they are not collinear. Okay, or let's say this and this, they are also not collinear. Okay, so this is not collinear, this is also not collinear. Equal vectors, that means, remember that love story, what happened some days back? Some days back, Pandu saw Champa and then decided to follow her. After that, they became boyfriend girlfriend. So what happens if Champa is moving like this, hand in hand, Pandu moves besides her, side by side, like this? Their magnitudes are same, their directions are also same. They are hand in hand, they are hand in hand, and they are moving parallel to each other. So in such a case, they are said to be equal vectors. Then also it means that the magnitude of C is equal to the magnitude of P, and also directions are same. And directions are basically going to be same. Yes, exactly. Next important thing. Okay, unequal vectors means their magnitudes could be different, directions could be different, anything is possible. So then they are said to be unequal vectors. That is very simple. Now, negative vector. So once they became boyfriend girlfriend, obviously they will fight also, right? Yes or no, my dear warriors? So imagine one day when they fought, Champa went this way, Pandu fought with Champa. He said, I will walk away from you exactly how much ever you move away from me. So then they are said to be negative vectors. So then P vector is negative of C vector. In such a case, direction is basically opposite, but the magnitudes are still equal. The magnitude of P is equal to the magnitude of C. That is what your negative vector is. Awesomeness. Good evening, Sebastian. Yep, very good. Amazing. Amazing. Lastly, angle between two vectors. Now, this is a very funny question. See, guys, imagine if I just give you two lines like this, which are intersecting, and I ask you measure the angle between them, then you are often confused. Sir, should I measure this angle? Or should I measure this angle? Or should I measure this angle? Or should I measure this angle? Now, out of all these four angles, at least two of them are equal. Like this angle is equal to this angle, and this angle is equal to this angle. So either I measure this or I measure this. So I have two options. I have basically two options. I have how many options? Two options. But when it is not aligned, now this was a line, let's say it is not aligned. For example, they are rays, they have direction, then you have no other option. You just have only one single option, and that is always think as if you can move them around so that their tails will coincide, as if they are originating from the same place. Like for example, this, they originate from the same place, or they start from two different tails, or they are starting from two different tails and they are ending over here at the same point. So wherever they start together or wherever they end together, measure the angle between them. Like for example, these two lines, measure this angle. So had they started from here to here, here to here, this is the angle that you have to measure. Or if they start from here, they will end here, or if they start from here, they will end here. This is the angle. Both of them are opposite. So this is the right angle to measure. Do not even think of measuring this or this. This is not the right angle. This is not the right angle. A lot of you might be thinking, should we measure only the smaller angle? The answer is no. So even if, let's say it is like this, even if it is like this, understand that right now both of them are starting together. So this is the angle which you have to measure. This is the angle which you have to measure. If I extend, if I extend this line, like this, like this, like this, so you will see this or this is not the right angle. This one is not the right angle. This one is not the right angle. You can also notice I can take this and slide it over here so that it feels as if it is over here. I can take this, slide it over here. It feels as if it is over here. Both of them are ending together. Then only you can measure the angle. Whenever they end together, or start together, that is the correct way of measuring. They should end or start together. They should end or start together. Same thing over here. Imagine this and this. Both of them are ending together. Both of them are ending together. Perfect. This is the correct angle, my dear students. This is the correct angle, my dear students. Either this or this. What is not correct is this or this. Same way, for example, I have a vector like this and I have a vector like this. These two have directions. Don't even think of measuring this. This is not correct because they are not starting together. So I have only one option, but to shift this, right over here. I have just basically shifted this right over here. Why? So that they both of them start together. Once they start together, then this angle is the correct angle. Then this angle is the correct angle. This angle is not the correct angle. This is not the correct angle. Understood, my dear lions? Now is it absolutely very clear? Absolutely very clear? Okay, when to measure the angles, when not to measure the angles. Okay, so let's have a look at some maybe questions coming up on your screen. In the figure shown, can you find out the angle between AB vectors in each and every case? Observe the arrow marks, their tails and their heads carefully. Observe their arrow marks and their tails and their heads carefully, my dear students. You can clearly see in this case, their tails are definitely together. So hence, whatever angle is there, you can directly measure it as it is. It will be 45 degree. Hence, 45 degree is the answer. In this scenario, you can see their heads are directly ending at the same point. Hence, whatever angle is there over here, that is the correct angle. Hence, that is the correct angle because their heads are ending together at the same point. So, 150 is correct. Here, the problem is head, tail are together, not head, head or tail, tail. So, I have to shift it. Either you shift this here or you shift that there. So, either ways, you will get the same answer. Bring that, slide that up slightly like this. Bring that, slide that up slightly like this. This angle was 145 degrees. If this is 145 degrees, then understand this is the right angle that I have to measure because this is not right. Here now both the tails are together. Exactly. Correct. Understood? So 145 will not be the correct answer. Understanding my point? 145 will not be the correct answer. So what will this angle be? 180 minus 145. How much is it? 35 degrees. Exactly. So 35 degrees is the correct answer. Awesome. This is how you measure the angles. Right. Now let's come to the actual vector addition. Now we have laid the foundation of what is vectors, how to represent it, what is the magnitude, etc., etc. So I think now it's a good time to add vectors. And there are multiple ways of adding vectors. But why are we studying vector addition? What is so special about it and what is so different about it? So let me tell you that as well. See, my dear students, when I give you numbers like 2 kg plus 2 kg and you say, sir, the answer is obviously 4 kg, sir. Perfect, no issues. If you say 2 seconds plus 5 seconds, you'll be like, yes, sir, it is 7 seconds. You just do normal addition, which you have been doing entire school life. But what is different now is that, for example, is this possible? 2 newtons, okay, force, 2 Newton force and 2 Newton force together give you 0 Newton force. 2 newtons and 2 newtons together give you 0 Newton force? The answer to that is yes, that is possible. But this would never ever be possible in case of scalars, that you add 2 kg and you again add 2 kg and what you get is 0 kg. This would never ever be possible. But that is possible in vectors. Newton's force is a vector quantity. I hope this is absolutely clear. Yep. Yes, Shanmuga, I will get problem solving sessions. That's why I'm saying there is some special surprise for all of you. This is possible. In fact, In fact, it is also possible, that 2 maybe meters per second plus 5 meters per second may be 3 meters per second. You'll be like, what? Yeah, this is velocity. This is velocity. So when I add 2 meters per second, maybe in some direction, and 5 meters per second in some direction, maybe it might become 3. You'll be like, sir, how is that even possible, sir? Maybe this was in the west direction, and this was, let's say, in the east direction. That might lead to 3 meters per second in the east direction. Just think about it. If I go 2 meters per second in the west, 5 meters per second in the east, this was 2, this was 5. What is remaining is this one, and that is basically 3 in the east. So this is what exactly vector addition is all about. It's about understanding or taking into account the direction. Yes, there is direction also. So that is why I have to be little bit careful. Yep, correct. So there are multiple ways of adding vectors. I will show you all the ways. Now you will be like, sir, how do I know? Will they give in the question? Add the following vectors using parallelogram law. Now in this question you have to use, you have to use analytical method. No, you will see how simple these laws are. Number one. Number two, looking at the question only, you can figure out which method to use. Sometimes there might be some confusion as to which method to use, but with practice, I think you will be comfortable. But you should know all these methods so that you are comfortable in using any one of them when the situation demands you to. It's not like this is important, this is not important. There is nothing like that. Throughout physics, you will be needing all these laws. So one is graphical, meaning you use diagrammatical methods. The second one is analytical method, where you are having a formula, substitute the values and you get the answer. Sometimes can be time consuming. Last one is the easiest one, where you represent it using IJK format. That is the easiest one. So we'll talk about all the three methods. Okay. Now let's talk about the first three methods, which are basically the graphical, the geometrical methods. One is called the triangle law. The second one is called the parallelogram law. The third one is called the polygon law. Just like the name suggests, triangle, parallelogram, polygon, they will involve exactly those geometrical figures. Triangle law will involve some triangle in between. Parallelogram will need you to have a parallelogram. Polygon means a multi-sided figure. A multi-sided figure. Exactly. You will need that to construct it. So let's see the triangle law. Then I will show you the subtraction. Then I'll show the parallelogram law and then the polygon law. Okay. All these methods I'm going to show you. So let's have a look at triangle law of vector addition. What does it exactly mean? Okay. So rather than just showing you the theory slide, I feel we should probably practically do it. Say for example, I have a vector A which looks probably like this, and I have a vector B which looks probably like this. And I want to find what is A vector plus B vector. What you should do is bring that A vector. This is how you are going to perform the operation. You bring that A vector, process. This is the simple procedure. You bring that B vector, slide it, zui, you bring it. But how? Where will you put it? You bring that B vector. Where will you put it? Such that the tail of B hits the head of A. B's tail is A's head. So think of it like this. A went like that. Then you continue along B. So you start from B's tail and go to B's head like this. Tail, head, tail, head. So that is how you arrange it. And then you see that these two are actually the sides of an imaginary triangle. This is the missing side. You draw the missing side. That is, oh, you will be wondering, sir, when you draw this line, should I put an arrow mark here or should I put an arrow mark here? The answer is, see, you started from here, right? And finally you came here. If finally you came here, obviously the final head should be here. So start and end. That's it. So this is your A vector plus B vector. This is your A vector plus B vector. Some of you will be like, sir, you did cheating, sir. You took A first because alphabetically A, B, C, D, E, F, G. So that's why you took A first. No, I can take B first. Let's take B first. And let's see what happens if I take B first. This is B. This is B. I took B. Now I will take A. Zui, I'll take this A. Okay, where do I put it? Where do I put that A? Such that B's head is A's tail. Such that B's head is A's tail. A's tail is this one. So bring that A's tail over here like this. This is how I do it. Oh, I can still see a triangle, imaginary one with a missing side. Complete the missing triangle. I started from here, I ended here, so I'll put the arrow over here. Ended eventually here. So this is B bar plus A bar. Oh, wait a minute. This and this look the same, pointed the same way. Amazing. Amazing. So this means whether I do A first and then B, or whether I do B first and then A, it is the same thing. It is the same thing. So that is said to be commutative. Commutative. For example, your mom tells you, listen, Pandu, or whatever your name is, Champa, go to the market, buy 2 kilo tomatoes, buy 2 kilo tomatoes, and also buy 5 kilo potatoes. Lot of guests are coming, buy 2 kilo tomatoes, and also from that market, tomatoes are nice, you buy 5 kilo potatoes. Now, whether you buy tomatoes first or whether you buy potatoes first, how does it matter? At the end of the day, when you come home, you should have those tomatoes and potatoes. If you bring watermelons and mangoes, you will get flying slipper on your face. So that is commutative. The order does not matter. The sequence of events does not matter. Then it is said to be commutative. Yes, as long as the final goal, this is the final goal, this is the final goal, that is same. Excellent. Are there some more examples of vector addition? Yes, using triangle law. Let's see the few more examples. This is, let's say, A vector. This is B vector. This is, let's say, A vector. This is B vector. This is, let's say, the A vector. This is, let's say, the B vector. Let's add A and B in every single scenario. Let's have a look at them. A and B. Oh, A started from here, ended here. Okay. Wherever A ends, B starts. So B started from here and ended here. Perfect. Oh, sir, there is no triangle, sir. Where is the triangle, sir? In this case, when I draw this, I don't see a triangle. Don't worry. This triangle is flat. This triangle is flat. Toop, it fell down. Usually our triangles are like this. Imagine these two sides fell down like some sticks. They fell down like some sticks. And finally, basically these sticks are fallen down like this. So imagine the triangle fell down. Toop. Okay. So guys, we have a missing side, but that missing side is from here till here. This is what A plus B is. Excellent. What about this? A and B. Okay. A is here. B should start from where A ended. So from here till here. This is where B bar is. So hence our resultant will be from here till here. So this is A bar plus B bar. How about this? Let's take either one. Let's take B this time first. No issues at all. It doesn't matter order. And now I take A and put it on B's head. Amazing. The moment I put it, I see a missing side. So this is basically A bar plus B bar, or B bar plus A bar. One and the same thing. Got it, my dear students? Very good. Amazing. Great. Clear. Very good. Let's move on. Let's move on from addition to now subtraction. You're like, sir, so quickly you came to subtraction, sir. Yes. Yes. You know, after a long time, I never understood subtraction when I was in school. After a long time, I understood what exactly subtraction is. Once I reached some 8th or 9th standard, I understood actually subtraction is addition of a negative number. So when I do 5 minus 3, what you are actually doing is you are taking 5 and adding minus 3 to it. And you are adding minus 3 to it. So subtraction, this is equal to, so is nothing but addition, of whom? A negative number. This is for scalars, but it is also true for vectors. Yes. So you're like, sir, do I know negative vectors? Of course. Just some time back, I told you about negative vector. Pandu Champa fought. Pandu went this way, Champa went that way. Directions are opposite. Magnitudes are same. So over here, if I want to do subtraction using triangle law, here is what I will do. I have been given this vector A and I have been told, listen, this is vector B. I want to do A bar minus B bar first. So I'll think A bar minus B bar means actually Shreyas Sir is asking A bar plus the negative of B bar. Ooh, what is negative of B bar? Negative of B bar is basically zup ulta. Take B bar and put it like this. This is negative B bar. Where is A bar? A bar is here, sir. Okay, let me slide it. Let me put here. Doesn't matter how I put it. Where I can put it here also, I can put it here also, and then the same thing. So this is basically AB. I just took it and put it here. That's all. So this is now in order. Tail, head, tail, head. There is a missing side. This is the missing side. Started from here, ended over here. That's the arrow mark. Hence, this is A bar minus B bar. This is A bar minus B bar. Perfect. Awesome. Okay. Sir, can you now do B bar minus A bar, sir? Okay, I will do it. B bar minus A bar is nothing but B bar plus negative A bar. Ooh, negative A bar. Zoop. Turn it opposite. Turn it opposite. Minus A bar. Minus A bar. Zoop. I turn it like this. So this is minus A bar. Okay, minus A bar is here, B bar, bring him here somewhere, head, tail. So basically something like this. Oops, something like this. Okay, so this is basically your B bar. Perfect. I see a missing side. This is the missing side. This particular thing is the missing side. Started over here, ended over here. So this is what it should be. So this is B bar minus A bar. Perfect. We got A bar minus B bar. We also got B bar minus A bar. Awesome. So now you will be wondering, sir, are these two equal? A bar minus B bar and B bar minus A bar. What do you guys say? Are they equal? Come on, my dear students. Is A bar minus B bar equal to or not equal to B bar minus A bar? The answer to that is no. So they are not commutative. Not commutative. But you know what is equal? You know what is equal? If I take A bar minus B bar's modulus and B bar minus A bar's modulus, yes, only they are equal. The magnitudes are equal. Only the magnitudes are equal. Keep that in mind. Exactly. Yes, perfect. And also keep this in mind. Also keep this in mind that directions are opposite. Here I can just say in these cases the directions are opposite for this one and for this one. See, A bar minus B bar is here, B bar minus A bar is exactly opposite to it. Exactly opposite to it. That is what it is. Cool. So that is subtraction using triangle law. We can do more such examples. Let's say, for example, you know, A vector is here, and let's say B vector is here, and I want to do A vector minus B vector on one side, and I want to do B vector minus A vector on the other side. Let's see in both the cases. A minus B. So B has to be taken opposite. So this is basically minus b. Is as it is over here. So this is a bar as it is. So this thing is basically your a bar minus b bar, starting from here, ending over here. Now when I do b bar minus a bar, I have to take negative of a bar. So negative of a bar is basically over here. Negative of a bar is basically like this. B bar, I will put it on top of it. B bar, I'm just going to put it on top of it as it is over here. I can see a missing side. So this is that missing side. I hope you can see that. This particular thing started here, ended here. So this is B minus A. Again, you can see they are both opposite to each other, but of the same magnitude. They are opposite to each other, but of the same magnitude. Correct. Very good. Excellent. Very, very nice. Very, very nice. Awesome. Awesome. Shall we go ahead? Shall we go ahead? Okay. Next comes parallelogram law. Just like the name suggests, parallelogram law. Obviously, there will be some kind of parallelogram involved somewhere. So, what is that parallelogram? Where is that parallelogram? Let's have a look. Imagine again, I give you some two vectors. This is, let's say, A vector, and let's say this is your B vector, and I want to add them using parallelogram law. In triangle, you place the tail of one on the head of the other. You place the tail of the one vector on the head of the other vector. But in parallelogram, don't do that. It's like taking two monkeys together. Parallelogram means just imagine somebody is holding two monkeys tails together. These are the two tails of the monkeys. This is your monkey. This is another monkey. They are upside down now. These are your two monkeys. You are grabbing, holding both the tails together. So parallelogram is like two monkeys together. Okay, two monkeys. So you will hold the tail of the monkeys. So let's hold the tail of the monkeys together. So A vector, zoop, it is like this. This is your A vector. B vector, again, hold it from here. It is basically like this. Basically like this. Perfect. Now you construct a parallelogram. You construct a parallelogram. How? I draw a parallel line to this like this. See, almost I'm trying to draw it as close as possible. Draw a parallel line to this. Okay, perfect. Can you see that? I'm drawing two parallel lines. Amazing. I saw a parallelogram. Now you bring one more monkey. The third monkey's tail also should be here. The third monkey's tail is also here. The third monkey is the resultant monkey, the net monkey. So you bring it from here till the opposite vertex. All the three tails are together. This is basically your A vector plus your B vector. As simple as that. So A vector plus B vector is your net monkey, resultant monkey, the vector addition as it is. Perfect. Very good. So now you might be wondering, sir, is this way different from triangle law? The answer is no. How? See, think about it. Think about it. In parallelogram law, okay, in parallelogram law, what you just did, you just took A vector here, you just took B vector here, just took A vector here, you just took B vector here, and then you constructed a nice, beautiful parallelogram, right? And then you saw this was the resultant. This was the resultant. Notice how this vector can be easily slided over here. Notice how this particular vector can easily be slided over here. Now this looks like a triangle law. Forget that. Even this vector can be easily slided over here. Now you can see again, if you hide this part, it's a triangle. If you hide the upper part, this is a triangle. So triangle law is a parallelogram law. Parallelogram law is a triangle law. Just look at it from different perspectives. That's all. It is just looking at it from different perspectives. Exactly. Exactly. I hope this is absolutely very, very clear. Absolutely very, very clear. Okay. So parallelogram law is nothing but triangle law. Just look at it differently. The missing diagonal, the diagonal which you start from the common tail, is the resultant. As simple as that. Okay, so that was your parallelogram law. Cool. Now, polygon law. Poly means many, gon is a multi-sided figure. So polygon. Triangle is the first polygon, the easiest polygon, then comes your quadrilateral, then comes your pentagon, then comes your hexagon, and so on and so forth. So polygon is basically an n-sided figure. Now you want to add many vectors. In life, you want many troubles, no issues. A vector is there, B vector is there, C vector is there, D vector is there, E vector is there, F vector is there. All these vectors you want to, bunch of people, you want to add them. Okay, you are like, call them one by one. Okay, you come first. Let's say, what is this? A. Let's say this is B, this is C. Okay, we took too many of them. Let's just keep 4 for now. Okay, so first bring A. Okay, A, you are here. B, where are you? Okay, you are like this. Okay, so wherever you end, start the next. Wherever you end, start the next. C, start it from here, like this. Okay, wherever you end, start the next. D, start it from here. Okay, so this is basically your D vector. Perfect. So let me just put C over here. Now, do you see the start and the final end? Just draw a line from the start till the end. That's it. And the arrow mark should be towards the end, of course. That is your A vector plus B vector plus C vector plus D vector. That is your resultant vector. As simple as that. That is law of polygon. By the way, it doesn't matter which order you add them. Let's say you started with C first. Let's say you started off with C only first. Okay, let's say you started off with C vector. Then you go to A, for example. Okay, then you went to A vector. Okay, something like this. Then you went to D vector. Then you went to D vector. Maybe D vector was slightly like this. Okay, then you went to B vector. B vector was somewhat like this. Somewhat like this. Okay, somewhat like this. This is your B vector. Again, if you join from here to here, whatever you get, which is C vector plus A vector plus D vector plus B vector, order does not matter. This and this is one and the same thing. The order does not matter. It is commutative. It is commutative. The order does not matter. Also keep in mind one more thing in case of parallelogram law. If by chance it happens that you have been given some vectors and you are adding them systematically by process. Okay, this vector done, this vector done, okay, this vector done, okay, this vector done, okay, this vector done, okay, this vector done. And in this process, you find that you end up at the original place where you began. So then your resultant will be a null vector. It's a null vector because you got a closed polygon. Because you got a closed polygon. Here, whatever you got was an open polygon. Open polygon. That means there was one side missing. There was always something was there which was missing. So this was that openness, that open polygon. Understand that. Here it is completely closed. That's a closed polygon. So the resultant is 0. It's a null vector. I can also say the resultant or the net is 0 or basically null. That is what it means. Exactly. Exactly. Very good. How about some questions? Read the statement. This is NCERT question. The magnitude of a vector is always a scalar. Each component of a vector is also a scalar. Component means a part of the vector. Actually, the total path length is equal to the magnitude of the displacement. Okay, actually, we should do this later on, not now. Hold on. This is not the right time to do this. We'll do this later on. Okay. Now, let's do this actually. This one will be interesting. If A vector plus B vector is A vector minus B vector magnitude wise, then show that A is perpendicular to B. That is the question. Okay. Show that A is perpendicular to B. That is the question. Everyone, let's do this. All right. Now you'll be like, sir, is there any formula? Oh, wait a minute, we didn't even see any formula till now. We're just doing everything diagrammatically, geometrically. So maybe we have to use geometry. Okay, let's do that. A vector plus B vector. So let's say this is your A vector. Let's say this is your B vector. So A vector plus B vector, A vector plus B vector. Let's say I show it here. This is your A vector plus B vector using our triangle law. Using our triangle law of vector addition. Everybody, I hope you can see that. Now I want to do A bar minus B bar. So minus B bar, think about it, will be the same B but in the opposite direction. The same B but in the opposite direction. Just like this. It's just the same thing but in the opposite direction. Perfect. So this is also triangle. Forget the top part. This vector and this vector. Forget the minus sign. It is just vectors one after the other. Tail, head, tail, head. So there is a missing side over here. There is a missing side over here. That's it. This is the missing side. And this is nothing but A vector minus B vector. Now, what does this modulus symbol say? Modulus symbol says magnitude. So the magnitudes are equal. Magnitudes are equal means if you take the length of this and if you take the length of this, they both are equal. Oh, very nice. That means if I take this and if I take this, they both should be actually equal, but I have not shown them equal. I have not shown them equal, but if I show them equally, just think about it for a moment. If I happen to show them, because this was just randomly drawn, I don't know what the actual side lengths are. If I show them properly, equally, something like this, guys, don't you feel this is like an isosceles triangle? Don't you feel that this is an isosceles triangle? Isosceles triangle. Everybody agree with this? Everybody agree with this? And this point over here, this particular point over here is the midpoint of the base. Is the midpoint of the base. And if I draw a line from the vertex to the base, this is the median. This is the median. Agree? A line which divides the side equally from the opposite vertex, that is called as the median. Oh, but we know this property from our 8th, 9th grade or 10th grade that a median of an isosceles triangle on the base is always the perpendicular. Or if it is a perpendicular, it is the median. If it is median, it is perpendicular. If it is perpendicular, it is median on the base. That means this angle or even this angle should be 90 degrees. It is not looking 90, but it should be. My diagram is incorrect. That is what it implies. Hence, it proves A is perpendicular to B. Hence, it proves A is perpendicular to B. Without even writing one line of mathematics. No equation, no formula. I proved it to you by pure geometry. This is something which I bet many teachers won't teach you. Formula wise, I will show you, but without formula. This is what is nothing but important. You should see the different perspectives. We'll do the same problem with formula, of course, in a bit. We'll do the same thing with a formula, of course. I have another question for you. How many vectors non-zero are basically needed for the resultant to be 0. For the resultant to be 0. Come on, let's see if you guys can answer this. How many bare minimum vectors will you need? How many minimum vectors? I think I should have added the word minimum. How many minimum vectors will you need? How many minimum vectors will you need so that the resultant is basically a 0. Okay, let's think. If I take a vector like this, 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 yes, the resultant is 0, but there are too many vectors. I want to reduce the number. How about this? This vector, and this vector. Oh yes, the resultant is still 0. If you notice, I started and ended at the same point. Can I reduce this even more? I think so. How about just going like this and just coming back like this? Oh, the resultant will be again a 0. So the minimum is how much? The minimum is basically 2. So the minimum number of vectors is basically 2. A lot of you said 3. 3 is not the answer. The answer is 2. And now I will change the question a little bit here and there. I'll change the question a little bit here and there. First of all, let me bring this here. How many minimum vectors non-zero? Okay, let it be. How many vectors non-zero of different magnitudes? Of different magnitudes are needed for resultant to be 0. For resultant to be 0. For resultant to be 0. Come on, my dear students. What do you think the answer for this particular question will be? What do you think the answer for this particular question will be? Think about it. Yes, in this particular scenario, these two vectors were of same magnitude, so this can't be the answer. The answer will be this. They are of unequal magnitudes, so hence the answer will be minimum is basically the number 3. Yes, you need a minimum of 3 vectors. Perfect. Awesome. Awesome. Now, I will give you some vectors magnitudes such that when you add the two vectors, you should get the third vector. I want you to figure out whether it is possible to have such magnitudes to satisfy this condition. The first one being, or I will call it as A, the first scenario being, this has a magnitude 2, this has a magnitude 3, this has a magnitude of 4. Is this possible to have these magnitudes and get these vectors being added so that the resultant is C? Second option, let's say, you have magnitude 3, this is also 3, and this is also 3. Is this possible or not is the question. This is 2, this is 5, and let's say this is 1. Is this possible or not? Just think about it. This is 3, this is 4, this is 5. This is D. Multiple options may be correct or wrong. This is 2, this is 7, this is 2. Okay, and let's say this is the final option. This is 7, this is 2, and this is 7. Okay, think about it. Which of the following are possible magnitudes which can satisfy this vector addition? A, B, C, D, E, F. Out of them, some are possible, some are maybe not possible. I'll give you a hint. Whenever you are adding, think of maybe, let's say, triangle law. So basically, some way or the other, triangle should be formed. And what is the fundamental property of a triangle? What is the, especially for the sides? If some side lengths are given, let's say this is A, this is B, and this is C, the sum of any two sides should be more than the third side. You take any side, B plus C should be more than A. You take C plus A should be more than B. This is the fundamental criteria for the sides. And if the triangle can also fall flat, completely like this, then this will be more than equal to, because then this side plus this side will be exactly equal to the third side. So that is why this is the criteria for a triangle, including a flat triangle, to be formed. So now imagine if this is the scenario, you basically have to think of, okay, we have a triangle or probably a flat triangle, and can it be formed or not formed? 2 plus 3, 5 more than 4. 3 plus 4, 7 more than 2. 2 plus 4, 6 more than 3. Yes, this is possible. Definitely, A option is possible. Agree? Everyone with me on this? How about this? 3, 3, 3. Definitely, it's an equilateral triangle, guys. It's an equilateral triangle. Definitely, it is possible. Just imagine you go 3 units here, 3 units here, and then you get the resultant as 3. All these sides are equal to be 3. All these sides are equal, 3. Definitely, it is possible. 2, 5, 1. 2 plus 1, 2 plus 1, guys, just check this out. 2 plus 1 is less than 5. So it is less. So this is not possible. You can't ever construct a triangle with sides 2, 5, and 1. Not possible at all. 3, 4, 5, yes. This is in fact a Pythagorean triplet. 3, 4, 5. 3 square plus 4 square is 5 square. So actually you will get a proper right angled triangle. So hence this is possible. It is following Pythagoras law. In fact, 2, 7, 2. 2 plus 2, just try to do 2 plus 2. It is easily seen 2 plus 2 is 4, which is less than 7. Hence, E option is not possible. What about this? 7 to 7. What about 7 to 7? This is definitely possible. 7 plus 2, 9, more than this. 2 plus 7, more than that. 7 plus 7, 14, more than 2. Yes, all the three combinations are working out. So this is possible. So this is possible. We have just used triangle law of vector addition. All we have done is used triangle law of vector addition. Nothing more, nothing less. Got it? Everyone with me? Understood how these laws work? Now let's go to the analytical method. Now let's go to the analytical method of adding vectors. It's very simple. I'll tell you what you should do. Just imagine there is one vector here and you want to add it with another vector. Let's say like this. And the resultant is right over here using triangle law. So I call this vector C, or you can also call it as resultant R. And this vector is basically A. This is basically B. I label these points. This is O. Let's say this is A. Let's say this is B. Okay, let's say this is B. I want to find the magnitude of R in terms of A and B. Now, A and B, there is some angle between them. Remember, whenever you want to measure the angle, you never place head with the tail. You need to slide the vector slightly so that their tails are arranged together. So, had you kept A vector somewhere here, then their tails will be together. Then this would be the correct angle for measurement. Agree with this? This would be the correct angle to measure the angle between A and B. So in order to measure how much is the value of R, and also I want to measure what is the angle made by R, let's say I call that as alpha, all we do is basically do some simple construction over here, and that construction looks something like this. Okay, drop a perpendicular. Let's call that point as C. Let's just call that particular point as C, where you drop a perpendicular. Now, look at that big triangle OBC. Look at that big triangle OBC. Use Pythagoras, and you will see this side and this side are perpendicular. This is hypotenuse. So therefore, you can say OB square is nothing but OC square plus your CB square. Correct? Now, what is OB? The length OB is the length of the vector R. So technically, OB length is basically R, so it is R square. Perfect. What is OC? Wait a minute. OC technically is OA plus AC. So it is actually OA plus AC. I need to square it. Plus, what is CB? CB is basically this length. Okay, so I'll just keep it as it is. Let me expand this and see what do we get. I get OA square. A square plus B square is A square plus B square plus 2AB. Plus, I'll get 2 OA into AC plus AC square plus CB square. AC square plus CB square. Look at these numbers, AC square and CB square. Look at AC square and CB square. In this small triangle, if you apply Pythagoras, AC square plus CB square will be AB square. So this is nothing but just AB square. So let us write down everything else. OA square plus 2OA into AC plus AB square. Perfect. Now what is OA? OA is the length of the vector A. So this is A square. So 2 times A. What is AC? I don't know that. I'll just leave it as it is. Plus, what is AB? AB is nothing but B square. Perfect. Can I write AC in terms of something else? The answer is yes. Just look at the triangle ACB. In this particular triangle, notice what is cos theta. Cos theta is adjacent side, which is AC, divided by hypotenuse, which is basically B. Therefore, AC is nothing but B cos theta. Use that over here. AC is nothing but B cos of theta. I've just substituted that. Oh, perfect. I think I've got the answer for my resultant. So my resultant, my dear warriors, if I take only R, this was R square. Remember, till this point, it was R square. So R will be, this was all till here R square. So R will be the root of this entire thing, the root of this entire thing. So it will be A square. Generally, we put B square first. And then I can just put 2AB and then you have cos of theta. That is the final formula for the resultant. That is the final formula for the resultant. Is that right, everyone? Understood? Got it? Very good. Now, let me also show you. You can also find the angle which is there over here, which is alpha. That's not that difficult. Okay, so let's find out the angle. And again, to find out the angle, let's look at that big triangle, triangle OBC. This was O point. This was our O point. Okay. So in the triangle OBC, if I just look at tan of alpha, what is it? Tan alpha. Tan of alpha is opposite by adjacent. Opposite is BC side and adjacent is basically OC side. Now, BC, I will just keep it as it is upon OC. OC is basically OA plus AC. OA plus AC. Perfect. What is side BC? Okay, actually, if you look over here, right, in this triangle ACB, if you try to find sine theta is the side BC by the hypotenuse, which is B. Therefore, the side BC is B sine theta. It's nothing but B sine theta. So instead of BC, I can just put it as B sine of theta. Perfect. What is OA? OA is basically nothing but the side length A. Is nothing but the side length A. And what is AC? AC is again from there. You can see it is nothing but B cos theta. But that is not what we want. We want tan of alpha or alpha. We want alpha. So alpha will be nothing but tan inverse of B sine theta upon A plus B cos theta. That is the answer. Tan inverse of B sine theta upon A plus B cos theta. Is this derivation clear? Everybody with me? Very important from your maybe board point of view, and also you should know it in general for NEET also. Okay, they won't ask derivations, but it is always better to know it so that you understand how things work. Right, perfect. Let's now see what is the formula for subtraction. This was for addition. A vector is there, B vector is there, resultant is A square plus B square plus 2AB cos theta. Angle made is tan of alpha is B sin theta by A plus B cos theta. Say it 100 times, 200 times, 500 times, but let it stick in your head. If it was subtraction, the only difference is there is a minus sign. Only difference is there is a minus sign. Same formula. Instead of plus 2ab cos theta, you use minus 2ab cos theta. Now I'll show you how this can make things easy for us. Somewhere back here, remember this problem? Remember this problem? What if I told you we can do it in a very different way using formula method? So if you use formula method, don't worry, this method is still there. This was geometrical method. Then I would say a bar plus b bar's magnitude, that means the resultant of a and b, will be a square plus b square plus 2ab cos theta, the whole thing under the root. A bar minus b bar's resultant means it is a square plus b square minus 2ab cos theta, the whole thing under the root. I hope this is clear. The whole thing under the root. Root goes. Okay, I hope you can see that the root value here and will go here. A square, b square will cancel. So what am I left with now? I'm just left with 2ab cos theta is minus 2ab cos theta. Bring that over here. It will become 4ab cos theta is 0. 4 is not 0, a is not 0, b is not 0. The only thing which can be 0 then is cos theta. When is cos 0? When the angle is 90 degree. Hence proved. So this is the methodical formula way of proving it. We did it also geometrically over here. I hope you saw how the formulas can be applied. Everyone clear till this point? Yes. So we can solve even more problems. Just look at this. Two forces each of magnitude F are acting as shown. Their resultant is. Very nice question, my dear students. Probably let's create a duplicate. Think about it. What should the answer be? I need this space for solving. Two vectors F and F, magnitude wise, you can see the arrows, the directions, angles are also mentioned. What do you think is the resultant? Okay, Pratibha Nag saying option C, sir. Okay, we'll see whether it is C or not. All right. First of all, the angle between the two vectors is not 60 degree. Let me tell you, because this is a head, this is a tail. So that is not the right angle. So slide this vector down. Keep this vector F horizontal as it is. Slide it down like that. Slide it down like this. This is also F. So realize one thing, very, very important. This angle was 60 degree, but that is not the correct angle. The actual angle between the two vectors is this one, which is 120. This is the actual angle. How many of you made that mistake? Got it? So this is how NEET will trap you. It's a very simple question, but it is all about how you get trapped. So the resultant will be using the formula a square plus b square plus 2 times ab cos theta. Let's use that. What is a over here? Both are magnitude wise f only. So f will come here 2 times a into b. Cos angle is 120 degrees. Perfect. So f will come outside because f is there many times. So I just take it out common. So 1 plus 2. Cos of 120 is negative half. So hence this will just become 1 plus 1 minus 1. Right? 2 cancels. It will become minus 1. So it will become f root 1, which is just f. Hence the answer to this particular question is just f. Hence the answer to this particular question is just F. As simple as that, which is option number B. Is that right? Yeah, answer is B. Correct. B for biology. B for your Baswa sir. Awesome. Very good. Perfecto. So you can have many more questions like this. Find the resultant. Find the resultant of two vectors at 37 degrees to each other, having magnitudes x and 5x. That is the question. So imagine there is one vector of x, another vector of magnitude, let's say, 5 times of x, and the angle between them is 37 degrees, and you have been asked, find what is the resultant. That is the question. Find what is the resultant. Simple formula, guys. Let's start with our formula. What is R? R is basically root of a square plus b square plus 2 into a into b into cos of the angle between them. A over here is x, b over here is basically 5x. A is x, b is basically 5x, cos of 37. X, 2 times everywhere. When I take it outside the root, it will just become x. What is there inside the root? 1 square. 5 square, 25 plus 2 into 5 into what is cos of 37? In case you have forgotten about it, no issues. Let me remind you of that magic triangle which I have told you about before also. So guys, 37, right? So if this is 37, this is 53, 53, 53, 53, 53. So this is 53 degrees, this is 37 degrees. So this is 4. So now you can see cos 37 is 4 by 5. Cos 37 is basically 4 by 5. Sin 37 is 3 by 5. Clearly, one can easily cancel this 5 over here and this 5 over here. All right. And see what do we get. X is common. Okay. 4 2s are 8. 8 plus 1, that's 9. 9 plus 25 is nothing but 34. So guys, don't let this big root. So yes, the answer is x root 34. X root 34. That is the answer. Is that clear? Everyone with me on this? Clearo? Pakka? Very nice. Very nice. Shall we go ahead? Understood now how to solve these questions on analytical method? All right. Let's see one more question. Let's see one more question. There are 3 vectors. Find the resultant. Find the resultant. Find the resultant. One vector is having the magnitude A. Other vector is also having the magnitude A. The third vector is also having the magnitude A. This angle are equal, and this is 90 degree. Okay, these are the 3 vectors which you have to add. These are your 3 vectors which you have to add. Now, the moment you see this question, you'll be like, okay, is there any formula that we need? I feel without formula also you can do it. Without formula also you can do it. It's a very easy problem because the angles are very nice. 90 degrees and angle bisector and all that. And since there are 3 vectors, I have to think of polygon, number 1. Number 2, see, I can choose whichever vectors I want to add first. Rather than adding it sequentially, I will choose the convenient vectors first. So I feel the perpendicular ones are convenient. So if I take A vector first, and then I take B vector, this one, perpendicular one next, and then lastly, I take this vector, I think that will be easier. I think this is very easy. Go like this, and then go like this. So I want to find the resultant of all of them. The best part being, let me tell you, if you just take these two, the resultant is like this. Their resultant is like this. And guess what? If this is A, and this is A, and this is 90, how much will this be? How much will that be? Think about it. It will be root of A square plus A square. How much is that? Take A outside. Take A outside. So it will be nothing but 1 plus 1. So guys, oops, that is nothing but root of 2 times of A. That is root 2 times of A. Is that right? Root 2 times of A. Perfect. Now, I don't have to find just that. I want to find the total resultant. The total resultant, this whole thing. Do not forget, this is also A, and they are all in the same line because this was 45 degree. Even this was also 45 degree, 100%, because these two sides are equal. This is also going to be 45 degree. And I also know one more thing, that this angle was also 45 degree. So both are one after the other. Both are one after the other. Is that right? So my students, what will happen? What will the resultant's length be? What will that green line's length be? Resultant will be root 2a plus a. If you want a common, it will become a root 2 plus 1. That is the resultant. That is the resultant. Correct. That is the answer. Everyone with me on this? Very nice. Very nice. Excellent, guys. Very good. Keep it up. Keep it up. Keep it up. Okay. Moving on. Moving on. Moving on. Moving on now. Let's take some special cases of maximum and minimum. This is also very, very important for you to understand. When is the resultant maximum? When is the resultant minimum? So, say this. Very simple. I will just draw the diagrams. You will only understand what I'm trying to do over here. In this case, both A and B are having 0 degrees. In this case, A and B is basically perpendicular to each other. In this case, A is this way, B is that way. It is basically at 180 degrees. Here, the angle between A and B is this one. That is basically acute. So from 0, it became acute, then it became perpendicular. Now remember, this is the angle. Why? Because you have to slide the vectors like this. The tails should always be together to measure the angle. Okay, the tails should be, sorry, that is not the angle, my bad. This is the angle. The tails should be together. So this is definitely obtuse. This is definitely obtuse. If you plot the resultant in every case using triangle law, this was the start, this was the end. That's it. This is the resultant. This is the resultant. This is the resultant. This is the resultant. And this is the resultant. Do you see the resultant becomes smaller, 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 eventually till it becomes minimum? Till it becomes minimum. So can I say this is the max value of the resultant? And over here is the minimum value of the resultant. That is when they are anti-parallel. That is 0 degree. 180 degree. So 0 degree means they are parallel. When they are anti-parallel, then the resultant is minimum. You can even use the formula to find it out. You can also use the formula to find it out, like a square plus b square plus 2ab cos of 0 degree. Cos 0 is 1. Now this is nothing but, cos 0 is 1. This is nothing but a plus b whole square. You take the root, it will just be a plus b. So guys, the maximum value of any vector is just the addition of the magnitudes. If you take the minimum magnitude, that will be root of a square plus b square plus 2ab cos 180. Do not forget cos 180 is minus 1, so it is minus 2ab. So hence it is root of a minus b whole square. When you take root, both plus minus will come, so better to put modulus, root of a minus b. So that is the minimum. Why I have put modulus? Because I don't know who is big. Is a big or b big? Is a big or b big? So I do not know that. So the minimum value is a minus b, the maximum value is a plus b. Every time else, the vector's magnitude will be lesser than this and more than this. So hence, in general, I can say my resultant will always be more than or equal to and less than or equal to, my resultant will be always less than the maximum value and more than the minimum value. So the minimum value being modulus a minus b, and the maximum value being just a plus b. So I will just put this over here. This resultant is nothing but a bar plus b bar's magnitude. So you would have seen this expression many places. This is the proof for that. Very, very interesting. Very, very interesting, my dear students. Okay. Till this point, I hope this is clear how this comes. Okay. Very nice. Find the magnitude and the direction of the resultant of two vectors A and B in terms of the theta and the angle between them. I think we just did that. Okay. That was basically your proof. This one. This one. Exactly. This proof is exactly the solution which is there in NCERT. Okay. Right. Now let's go to resolution of vectors and unit vector notation and all of it. So before that, we'll just take a 2-minute, 3-minute break. I just want to drink some water and we'll come back. Okay, we'll just come back in some 5 minutes. Just give me 5 minutes and we'll be back. Okay, just take a small break. Hey, my dear warriors, I hope I'm audible and visible to all of you again. Back, ready, excited, full of energy? Okay, let's begin. Let's begin. The break time is over. Okay, so let's understand what is the resolution of vectors. Let's understand what is resolution of vectors and unit vector notation and all of that. See, when I say resolution means it is basically splitting of a vector. So if you have a vector and basically you do a process of something called as splitting the vector. Split the vector. That process is called as resolution or resolving a vector. And what do you split into? If you have a big TV, you break it into parts. You have some block, you throw it down, it breaks into parts or components. So basically you split it into something called as the components or nothing but parts. So then you might be wondering, sir, how many ways are there, or can I split a vector into many ways? The answer is yes. For example, imagine there is a vector like this. I say resolve this vector. Like, okay, so what's the condition? Whatever the parts are there, when they are joined back together, they should produce the same resultant. Then you are like, okay, fine. I can think of so many ways of splitting that vector. One way is there is one component here, one component here. Another is one component here, one component here, another component here, another component here. Notice what is happening. Starting is here, ending is here. You are using law of polygon. You start and end as per the original vector's tail and head. This is again law of polygon. You are starting from here and ending over here, precisely matching with the law of polygon of vectors. You can also split it like this, then like this, then like this, then like this. Perfect. This is also definitely components. I can then say this, 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 and this. These are also components. Their resultant is still the same as the original vector. So how many ways are there? If you ask me, there are infinite ways. There are basically infinite ways of resolving a vector, of resolving any vector. Can you see that? There are infinitely many ways. Correct? Very good. But out of all these infinite ways, only certain ways I feel are more relevant to us, are more easy to understand, are easy for solving the questions. Which are those easy ways of vector resolution? That is, when the components or the parts are basically perpendicular to each other. They are perpendicular components or perpendicular parts. Then it makes the job easy. Your job is easy. Why is it easy when they are perpendicular? Because you can use Pythagoras theorem. You can use also trigonometry. You can use properties of right-angled triangle. Right-angled triangle properties you can use. All the different properties of a right-angled triangle. So these are the three main reasons why it makes the job easy, and that's why you consider splitting it into perpendicular parts. So that is why if you have a vector like this, I'll be like, wait a minute, I can take one component like this, another component like this. Perfect. Now they are perpendicular components. Same way, if I have a vector like this, I'll be like, wait a minute, I know what to do. I can take a component like this and I can take a component like this. It's one and the same thing, guys. Remember, I can always shift this over here. It's one and the same thing. Or I can even shift this over here. It's one and the same thing. If I had a vector like this, again I can split it into two components, one component here and the other component over here. The resultant is still the same. I could have placed this vector over here also. It's one and the same thing. It's one and the same thing. I could have taken this over here. If I had a vector like this, I could have split it into one component like this, another component like this. You can see if I place this over here, I still get back my original vector. Or if I take this vector over here, I still get back my original vector. So all of these cases, you can see their components are basically perpendicular to each other. And that is why it makes the job easy. And these components, which are perpendicular to each other, what are they called? They have a name. They are called as rectangular components. What are they called? They are called as rectangular components. So we will always resolve a vector. We will always resolve a vector into rectangular components because of the ease of calculations or usage. As simple as that. Hello, Mithun. Okay, that is rectangular components. Now, we'll see some interesting thing about these things. Rectangular components. Let me just go on to the slide over here. Imagine I take a vector like this, and I know that this is my x-axis, this is my y-axis, and if I split the vectors along the x direction and along the y direction, if you see, this is actually, you can use parallelogram law also to split it, or if you want, this is our vector v. I can also use triangle law. That means one vector here and the other vector here. So this is using triangle law. This is using parallelogram law. As simple as that. One and the same thing, both are the same. You can see both the components are perpendicular to each other. When this happens, then the component along the x-axis is called the x component. The component along the y-axis is called the y component. Component along the x-axis, x component. Component along the y-axis, the y component. As simple as that. Okay, these are the x and the y components. These are the x and the y components of our original vector. And you will see, if you add this x component and y component either using parallelogram or the triangle law, I will get back my original vector. I will basically get back my original vector. So these are the components of that particular vector. This is in 2-dimension. Mind it, if it was in 3D also, I could still do it. If it was in 3D also, I could still do it. It's just that I will need 3 axes. I'll need x, y, and let's say z. And maybe there will be one component over here. Maybe there will be one component over here. And maybe there is one component over here. This is x component. This is our y component. And this is our z component. And together, I will get my resultant vector. Together, I will get my resultant vector in 3-dimension. In 3-dimension. So this vector will be nothing but a combination of the x component, the y component, and the z component. All three together gives me that vector in 3-dimension. In 2-dimension, I just need 2 axes or 2 directions or just 2 components. Usually this is what we'll be saying. 3D questions are very rare. Even if it comes, it is very straightforward. Is this part clear, everyone? Now, once you understand, okay, if I know the axis, I can split the vector into 2 components, x and y. Sometimes these components are positive, sometimes these components are negative, depending on how the vector is oriented. Like for example, over here. In this case, versus this case, versus this case, versus this case. All possibilities we are considering. Observe it carefully. Okay. Okay. In the first case, the x component is here, y component is here. The x component is along positive, y component is also along positive. In this case, x component is along the negative side and the y component is also along the negative side. Can you see that? The y component and the x component both are along the negative x direction. In this case, the y component is along the positive, the x part is along the negative x. The x component is along the negative x. In this, x component is along the positive side, the y component is the one which is along the negative side. Can you see that? So this is how your certain components might be positive, negative, depending on which direction are they oriented, up, down, left, right, positive side, negative side, etc. I hope this is very, very clear. Now, if you understood till here, think about it and tell me, if the vector lies like this, or if the vector lies like this, what are the x and the y components? What are the x and the y components? Think about it carefully. The vector itself is like this. What do you think are the x and the y components, my dear students? In this case, there is x component, but I feel there is no y component. The y component is 0. There is nothing to go in the y direction. In this case, the x component is 0. Rather, the y component is the only one which is present here. Just check this out. Yep. So, if a vector is on the axis, then the other component becomes 0. If a vector is on the axis, the other component becomes 0. Vector is on the axis, the other component becomes straightforward 0. Can I measure these components? The answer is perfect yes. That's not a problem at all. See guys, if I am given a vector like this, okay, and let's say these are the x and the y components. This is our x component. Let's say this is our y component. And let's say this is like this. This is like this. If by chance I know this angle, which I call it as, let's say, theta, then the x component and the y component are given as follows. The x component and the y component are given as follows. Just remember this phrase. Just remember this phrase. Cos C. C for close. Sine is a sin. You commit a sin. You commit a sin by going far. You commit a sin by going far away. What does this mean? Out of these two components, who is closer to theta? Who is closer to theta? It is the x component. So hence, I would just say Vx is V times cos theta, and obviously if you take V below, you can clearly see cos theta is Vx by V, adjacent by hypotenuse. So likewise, it makes sense. It makes sense. Vy is far from theta, so it is sine component, V sine theta. As simple as that. As simple as that. You can also see one interesting thing. By the way, I can also draw it like this and then like this. This is also perfectly okay. There is nothing wrong. Then this will be Vy. This will be Vx. Correct? If somebody measures this angle as theta, then for them, see how things will change. If you measure it with vertical, y is closer, so y will be close is cos, so v cos theta. X is far from theta, so this will be v sine theta, as simple as that. So this is how you decide the magnitudes of the x and the y components. Exactly. So depending on how you are measuring it, we can take very simple examples to make you understand this. Imagine this is 10 units and let's say this is 30 degrees. If I want to figure out what are the x and the y components, so one is the component here, other one is over here. So the x component, you can see, is closer. That means it will be cos. So it will be 10 cos 30. Y component is far away from theta. So it will be 10 sine 30. As simple as that. Let's take more examples so that you understand this. Imagine there is a vector having magnitude 24 and let's say this angle is 60 degrees. So now how do you split it? One part will go here towards the left side and the other part will go like this. This is your x component. It is negative because it is going towards the left side or opposite to the positive direction of x. So this is far from 60. So that's why it will be sine component. So 24 sine of 60. This one is closer to 60. So the y component is positive also. It's going positively. So 24 cos of 60 degree. As simple as that. Similarly, we can take even more examples. Let's say there is something which is going down like this. And let's say this is, let's say 20 degrees and this is nothing but 100 units. 100 units. Now, how do I split it? One component over here and the other component over here. The y component is far from 20 degrees. So it is sine. So 100 sine 20 degrees. X component is closer to 20. So the x component will be 100 cos of 20. But this will be also minus and this will be also minus because both are towards the negative side. Both are towards the negative side. As simple as that. Next, let's take one more example. Let's say it is something like this. And let's say the angle made is anything. Let's say 50 degrees. And let's say this is 16 units. How do I split the components? One component will be here. The other component will be here. The x component will be positive because it is going right positively. So it is far from 50. So it is 16 sine 50 degrees. The y component is closer. So it will be cos and it is towards the negative side. So it will be 16 cos 50 degrees. Is that now clear? How do you find the magnitudes of the components? How do you find the magnitudes of the components? Sometimes the axis could be tilted. That is possible, guys. Imagine there is a vector like this and maybe our axes only are tilted. Maybe our axes are only tilted, something like this. Sometimes happens in inclined plane questions. Sometimes it happens in inclined plane questions, guys. The axes only get tilted. Maybe this is like this. It's the same thing. There is nothing different. Imagine this was 200 and let's say this was maybe 40 degrees. Let's say this is 50 and let's say this is 15 degrees, something like this. Okay. Or we can even give this angle maybe. Let's say this is 70 degrees or something like that. So how do you take the components? You split it. One component here, other component here. Here, one component like this, other component like this. This is x component. X is close to 40 and it is in the positive direction. So it will be 200 cos 40 degrees. This is y component. It is far. That means it will be sine. So 200 sine 40 degrees. As simple as that. Here, both the x and the y components are in the negative direction opposite to the positiveness. So the x component will be negative. Even the y component will be negative. How much is this y? It is close to 70. So it will be 50 cos 70 degrees. This is far away. So it will be sine. So 50 sine 70 degrees with the negative sign. As simple as that. Now, I hope this is very, very clear, especially this resolution part. You should never ever be confused regarding vector resolution. What is their magnitudes? What is the meaning of resolution? Why do we take perpendicular components only? Why not any other components? Is it absolutely clear? Have you smashed the like button? If you have not done that yet already, please do that. Thank you, Krishna. Thank you, Jay. Thank you, Pratibha, Pavitra. Yes, thank you, Saptishri. Thank you. Thank you so much. Yes, perfect. Perfect. So now that we have understood this, let me tell you the final secret, which is the unit vector notation, That is the final part, so that we see the final way of vector addition then. See, imagine I tell you, I had a vector whose magnitude was 5 units and it was making 37 degrees. Then I split it up into components. One component here and the other component over here. This would be the x component, this would be the y component. Then I figure out what will be the magnitude of them. This will be cos component. So it is 5 cos 37. Cos 37, how much is it? It is 4 by 5. So hence it will be 4 units. Y component will be nothing but sine because it is far. So 5 sine 37. Sine 37 is nothing but 3 by 5. Is 3 by 5. 5 cancel. So it will be 3 units. So therefore, if you see what the actual components are, Vx and Vy, Vx is basically 4 units, Vy is basically 3 units. That's all I have done. Okay, till this point. I took a vector, I split it, I found the magnitude of the components, and I just wrote it down. Now the next step is, I remember vaguely that I had talked about unit vector and the special unit vectors along x, y, and z axis. And the special unit vectors along x, y, z axis are I cap, j cap, and k cap. So how about showing those over here for now? This is I cap and this is basically j cap. How many such I caps will fit in here? If this is I cap and this is j cap, just think about it. How many such I caps and j caps will fit in over here? Here, I cap will come 4 times because the length is 4. Oops. So I cap will basically come 4 times. Here, it will just come 3 times. Interesting. Now, I just remember one more thing. If our original vector was V, and I remember also writing this, it is actually Vx bar plus Vy bar. What is exactly Vx bar? You take I cap, but you take it 4 times. 4 times of I cap is basically Vx bar. Do you agree with it? I cap, I cap, I cap, I cap 4 times. And what exactly is Vy bar? You take j cap 3 times. So 3 times of j cap is Vy bar. So that gives me my total vector. Oh, this is so nice way of writing any vector in terms of I cap and j cap. This is called as the unit vector notation. What is this called? The unit vector notation. Such a nice way. All starts with a simple thing of taking a vector, splitting it up, writing their magnitudes, then thinking about I cap, j cap, and then thinking how many times does it come out. That's it. So any vector can be written down in terms of I cap, j cap, which is very, very simple, easy, and convenient. All right. Now, if somebody asks you, hey, can you tell me the magnitude of the vector? Can you tell me the magnitude of the vector? I'll be like, okay, yes, magnitude of the vector. Magnitude of the vector, that is nothing but V bar modulus. It's basically the length of this. Oh, I know what it is. It is nothing but root of, you just take x component square, y component square under the root, you will just get the magnitude. So it is root of 25, which is just 5, which is basically the length of this. So if you take the x component and the y component square using Pythagoras, you get the length or basically magnitude. So this means now I can finally understand and write it down properly. Unit vectors. Observe this carefully now. First, let me. This is x. This is y. Are you able to see a cube, my dear warriors? A very faint cube I have drawn. Deliberately, I have drawn a very faint cube. Okay. Now observe these things. Imagine your original vector from one corner to the other corner. Just imagine your vector from one corner to the other corner. It's like a room and you're going from one corner to the other corner. Opposite, diagonally opposite. Yep. And if that is my original vector, if that was my original vector, it has three components now. It has basically three components now. Observe those three components carefully. One component is right over here. Then one other component is right over here. And the other component is right over here. So this is our x component. This is our y component. And this is our z component. Of course, there is I cap, j cap also. So there is I cap over here. Then there is j cap over here. And of course, there is also k cap over here. Okay, all of this along x, y, and z. So whenever you have to visualize vectors in 3D, actually visualize a cube or a cuboid and then draw the vector diagonal from one vertex to the other vertex, and the sides of the cuboid become the components. The size of the cuboid basically become our components. So strictly speaking, our vector v is nothing but Vx bar plus Vy bar plus Vz bar. These are the three components. But in terms of the magnitude, in terms of the magnitude of the components, Vx, Vy, Vz and the unit vectors, it will be Vx I cap, Vy j cap and Vz k cap. Vz k cap. So this is in the magnitude form. Unit vector form. And if you want the final magnitude of the vector, if you want the final magnitude of the vector, you just take their x components, y components and the z components, square them, add them and place it inside the root. That will give you the magnitude of the vector. So this is how you represent any vector in unit vector form and also find the magnitude of it. As simple as that. Everyone clear till this point? Pakka? Okay. Very good. Let's solve some questions. Can you think of a vector A which is like minus 2 I cap plus 3 j cap? Think of a vector B which is like minus I cap minus j cap. Think how they look like. Okay. So over here, minus 2 I cap means along the negative x direction, I have gone 2 units. So go 2 units like this. So this is minus 2 I cap. Then 3 j cap. So 2 units towards the left. So minus 2 I cap. And then 3 units towards the vertical direction positively like this. So this is 3 j cap. So hence our actual vector will be like this. This is what our actual vector will be. If somebody asks you what is the magnitude, you just take the root. So it will be minus 2 square plus 3 square, which is nothing but 4 plus 9, which is basically root 13. So root 13 is the magnitude of that vector. Then how about imagining this particular vector? Minus I cap minus j cap. So minus I cap is right over here. Minus j cap is right over here. So the resultant of these two will be somewhere like this. So this is how you can imagine B vector. So if somebody asks you what is the magnitude of it, components are 1 and 1 both. So it will be just root of 2. It will be just root of 2. Perfect. Next, if somebody asks you what is the magnitude of I cap minus 2j cap plus 3k cap? Okay, if somebody asks you what is the magnitude of this, what will you do? They are just asking you the magnitude. That means you have to take the root, take the components, square it, add it, place it under the root. So this will be 1 plus 4 plus 9, which is root 14, which is basically root 14, as simple as that. Very good. Now, if they ask you a question, which of the following are unit vectors? Which of the following are unit vectors? Which of the following are basically unit vectors? And the options given are I cap minus j cap, I cap plus j cap plus k cap, I cap by root 2 minus k cap by root 2, I cap by root 3 plus j cap by root 3 minus k cap by root 3. This is option A, this is option B. Multiple options can be correct. Out of these options, which vectors are unit vectors, which of them are not? Just find the magnitudes, my dear warriors. Just find the magnitudes of all of them. If you take the magnitude of them, this will be nothing but 1 square plus 1 square, which is basically root of 2. Hence, it is not equal to 1. Therefore, it is not a unit vector. It is not equal to 1. As simple as that, it is not going to be a unit vector. How about the next one? This one. Magnitudes of the components are 1, 1 and 1 only. So 1 square plus 1 square plus 1 square is basically root 3. Again, root 3 is not 1. So this is also not a unit vector. This is also not a unit vector. Let's take the third one over here. So the magnitude of the vector will be 1 by root 2 whole square plus minus 1 by root 2 whole square. Whether there is plus or minus does not matter. Once you square it, it becomes positive. So it will be half plus half, which is basically 1. So root of 1 is 1. So it is a unit vector. So option C is a unit vector. What about this? So root of 1 by root 3 square plus 1 by root 3 square plus 1 by root 3 square, which is nothing but 1 by 3 plus 1 by 3 plus 1 by 3, which is 1, whose root is again 1. So this is also a unit vector. Very nice. C for capto, D for doctor. Yes, these are unit vectors. Now, sometimes the question can be slightly different. What is alpha so that 0.2 I cap minus alpha j cap plus 0.4 k cap is an unit vector? Is an unit vector? That is the question. How do you solve such a question? I want this vector to be unit vector. That means I want the magnitude to be 1. So therefore, I want the magnitude to be equal to 1. What is the magnitude? You take that vector, take the components 0.2 square, then alpha square, the minus sign doesn't matter, and then 0.4 square. The answer should be basically 1. So square both sides and see what is 0.2 square. 0.2 square is 0.04 plus alpha square plus 0.4 square is basically 0.16, is basically 1 square. I have squared both sides. 1 square is again 1. So alpha square will be 1 minus 0.16 minus 0.04. 0.16, 0.04 is 0.2. So this will just become 0.8. 1 minus 0.2 is 0.8. So alpha square is 0.8. So alpha will be root of 0.8. So you will find the options which has root of 0.8 and you will mark the answer. Everyone clear how to solve these questions? Now there is another kind of question which you generally get. It's something like this: finding an unit vector along something, along some vector. Finding a unit vector along some another vector. What is this? Imagine you have been given a vector, something like this, and I call that vector, let's say A vector, and you have been asked, can you just figure out what is A hat? You want to find a unit vector along some another vector which is not a unit vector. This is having some length, this is not that some length. Okay, I'll tell you what, think about it. If I write A bar, it will be some number of times of A hat. A hat, what is the magnitude of A hat? Think about it. A hat's magnitude is basically 1, right? A hat's magnitude is 1, right? A hat's magnitude is basically 1. So think about it, my dear students. If A hat's magnitude is 1, how many such 1 units will fit in A bar? This length could be 7 units. If this is 7 units, 1, 1, 1, 1, 7 times. If this is 5 units, 1, 1, 1, 1, 5 times. If this is 100, 1, 1, 1, 100 times. So, how many such A bars basically fit over here? How many? Basically, the magnitude times of basically A hat. Make that complete length, because this whole length is nothing but the magnitude of A. The length is basically the magnitude of A. That is how many, that could be 7, 8, 100, whatever. So that many times of A hat will fit in over there. So therefore, can I just say it is nothing but, this is nothing but magnitude times the unit vector, which is basically A hat. Therefore, A hat is nothing but A vector divided by the magnitude. A vector divided by the magnitude. This is again a very important formula. This is again a very, very important formula. Clear till this point? Clear till this point? Very good. So, if this was a question and the question was find the unit vector in the direction of this, what will you do? Okay, let's use our formula. So we have to find A hat. A hat is basically nothing but you take the vector A upon the magnitude of it. What is a vector A? It is 5i cap plus j cap minus 2k cap. What is the magnitude? Take components, square it, and then add it, put it under the root. So this will become 5i cap plus j cap minus 2k cap, whole thing divided by root of 5 square is 25 plus 1 plus 4. This is nothing but root 30. So this will become 5 divided by root 30 I cap plus 1 divided by root 30 j cap minus 2 divided by root 30, and this is k cap. So this is basically your a cap. So this is the unit vector in that direction. That's a long vector in that direction. That unit length is having this particular components. That is what it means. Very good, Krishna, Avisha. Awesome. Perfect. Awesome. 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 Now that you understand what unit vectors are, how to represent, how to split vectors, you understood all these things. The last part, remember the analytical part, addition in terms of unit vector. Just at the start of the class, somewhere over here, I told you there are multiple ways of adding the vectors, and we started our class only like this. We finished triangle, parallelogram, polygon. We also did analytical, which is the formula way, root a square plus b square plus 2ab cos theta, blah blah blah. We did that. Last thing is in terms of ijk. In terms of ijk, how do you add or subtract? This is the most difficult way, is it or no? Let's figure out. Let's figure out. Let's go. My goodness. Handling this. See, if you have a vector like 2 I cap minus 3 j cap plus k cap, three-dimensional. This is 4 I cap plus j cap minus k cap. Again, 2 I cap plus 3 j cap plus 4 k cap. This is I cap minus 2 j cap minus, or let's say plus k cap. Okay, these are the two vectors. In the first case, you are adding them. In the second case, you are subtracting them. What is the answer? Answer is so simple, guys. Just treat I with I, j with j, k with k. Don't mix up the variables. So guys, just see over here, 2 plus 4 is just 6. So it is 6 I cap. Minus 3 plus 1 is minus 2. So minus 2 j cap. Plus minus cancel. So no k cap only over here. Answer is 6 I cap minus 2 j cap. It becomes so easy when you add or subtract in terms of unit vector. So simple. Here you just do the normal subtraction. 2 minus 1 is 1. So 1 I cap. So 1 I cap. This is 3 minus minus 2 will become plus 2. So it will become plus 5 j cap. This will be 4 minus 1, which is basically 3. So 3 k cap. So I cap plus 5 j cap plus 3 k cap is the answer for vector subtraction. So the simple logic is whenever you have to add and subtract, just add x with x, y with y, z with z, or subtract x with x, y with y, z with z. That's it. That's the simple way to add or subtract in terms of unit vectors. So straightforward. So that was your addition and subtraction. That was your addition, subtraction, the major operations of vectors chapter, okay, which we have done today, including resolution and finding unit vectors along some direction. Also, we did the different types of vectors, and I'm pretty sure you would have enjoyed this class. And if you have enjoyed this class, leave a comment below how much you enjoyed. Now, the most important thing is, fine, you are studying in YouTube, but sir, I want to study more under you. So is there an option for me to study with you, to get guided by you, to get mentored by you? Not just you, the entire Vedantu NEET English team. The answer is yes. And the answer is there right in the comment section, or even the live chat, or even the description box. There is a pinned message, guys. All you need to do, where did it go? Yes, just go down over here in the description box and you will see the DNA batch. Register now. Just click on this. Now, what is this DNA batch? RNA is on YouTube, DNA is on the platform. On the platform, do I teach on the small screen? No, it's the exact same experience. You have a big board, you see me big, everything happens on the very same board. In pure English, it's a proper batch, and this continues till May 2025, including revision, including entire syllabus coverage of 11th and 12th. And you have the same teachers along with the other teachers who are at least so experienced that they have produced not hundreds but thousands of ranks in the NEET exam. You also will get digital study material including notes, including coaching modules, which is the Tatva, which has solved examples, PYQs, graded exercises level 1, 2, 3. You also get additional books so that you don't pay additional money to buy any other book. You also get DPP generation. You also get assignments. You also get doubt solving in the class. And you also get all India level test series. You also get class test. You also get revision. You also get support and mentorship from us till the end. You might be wondering, what is the cost? Is it 1 lakh? No, it's not 1 lakh. Is it 3 lakh? No. Is it 39,000? No. It's 3,999 rupees. That affordable. So we made this batch very affordable for you. There is an entry point going on. The batch just started now. If you are watching this video probably after a few days, you still can join it. You still can enroll. You still can cover up. And I'll tell you how to do that. Once you're joined, you can message me. We can have that mentorship. Guys, this batch is going to be the batch for 700 plus. There might be a lot of batches online. You check, you do your homework, you will see that many of them don't even complete the syllabus. Many of them, don't even provide half the things that we are providing. They say something and they do something. So be very, very careful. So make your right choice, make the right decision, and we want to ensure that you not only improve your scores, but you get into your dream medical college. So this is that batch. So check out the link, click on buy full course, and you are enrolled. Thank you so much. I would love to see you. And I'm so glad that you guys attend this session. Leave a comment after the session is over. Bye-bye. Captain Shreyas signing off. Hasta la vista.